Tonight, we're working on Chapter 6, which is all about files. Part of this chapter you are not responsible for. Exceptions, you are not responsible for exceptions. And I believe that kicks in on page 324. So if you look at page 324, you'll see exceptions starts there in the middle of the page. Stop right there. All you have to know in this chapter is up to page 324. We're not covering exceptions. So what we're going to do in this chapter is we're going to learn how to use Python to create ordinary text files and also read them as well. Okay, the whole point of creating a file is that you want to read it later. It's for storing information. And we're going to be using ordinary text files. That means human readable files. They'll have a particular file name extension. Does anybody happen to know what the file name extension of a text file is? Anybody? I think it's the same on a Mac or a PC. It's .txt. Anything that's named with a .txt, you can open it with Notepad. Windows Notepad will create a .txt file. And well, you can open a file with Windows, a TXT file with Windows Notepad. Well, that's what we're going to be working with here, human readable files. Now, in fact, there are other types of files that are not human readable. They're so-called binary files that if you try to open them in Notepad, you'll just see a lot of weird characters and special symbols and so on. It's not human readable. So this is just human readable files tonight. Now, the first thing I want to say about this, which is extremely important to remember throughout this chapter, all of your input or output deals with strings. If you want to read a file, what you're going to do is you're going to read strings. If you want to write something to a file, you can only write strings to the file. So if you have an int or a float and you want to store it in a file, you have to use the str function to convert the string or float, pardon me, the int or float into a string before you write it to the file. Okay, that's a key point. All of your input and output is strings only. And that's true in any programming language, by the way, not just Python. Well, I've got a couple of examples prepared, and we'll work through them. Here's the first one. I called it Makefile1. I'll make all of these files available in the links and resources section of our course page, which is also where the video will be after it's processed. Okay, so look, we've got Makefile1. We're going to save some names entered from the keyboard to a file. We're going to call that file pals.txt. Well, here's how you'd work that out. First of all, you have to use the open function. The open function is used whenever you want to use a file. What you specify inside the parentheses are the name of the file inside a string, and then the mode. And in this case, we're initially wanting to write some data to the file, so we open it in write mode, which is what the W specifies. Now, whenever you work with the file in a computer program, you have to have what's called a file object that interfaces with the file. It's like the connection to the file in your program. And in this case, we're going to call that my file. So this is actually what you call a file object. Sometimes it's called a file handle. And it's the way that we can connect our program to what's going on our computer and on the disk where we're storing information. So the first thing we want to do whenever we're getting input from the keyboard is we have to use the input function. And because we're just looking for names, input alone is enough. We don't need to use int or float, right? So we're going to enter, whatever we enter is going to get stored in this variable, pal. And then here's that concept for detecting an empty string. While pal is not equal to an empty string, this is an empty string here. So this loop will continue to cycle as long as pal is anything but an empty string. While pal is not an empty string, means keep going while it does have data. And what we're going to do is we're going to use the write method of the file object. Our file object, myFile, has various functions or methods that I can call. In this case, we're going to use the write function. And we're going to write the PAL that was entered and a \n to put it on its own line. So that'll finish the line. So that's going to write one line to the file. Now, we have to continue entering more names. So we actually duplicate this line here. It's an exact duplicate. I actually copy-pasted it down here. And this is called the continuation read. It has to be inside the loop. And this will continue to cycle until the user presses enter here, which would then make it an empty string, and that would stop the loop. And we always should close the file by using the close function of our file object. So let's give this a run. Here we go. And it runs like this. So we're going to enter the name of a friend or enter to quit. I'll go with Denny, Kenny, Lenny, Jenny, Penny, Benny. I can't think of any names, so I'll press enter to quit. Okay, that stopped the loop. Let's see what happened on our disk. It should have created a file called pals. There it is. I just opened it up. All I had to do is double click on it. Now I'm creating all these files in one folder. So the file will be in the same folder as the program. That's important. And as you can see, it has the names in exactly the same order that I entered them, and each on its own line. Each name on its own line. So it's just that easy to create a file with some names in it. Now, to make that useful, of course, what we want to do is we want to read that file. So we have a counterpart file here called read file 1. Just open that up and take a look at it. See how it works. Here's the program that's going to read the file. We once again use the open function, but now we're going to open this file in read mode. We specify the file, an R for the read mode, and I'm using myFile again. Now, I don't, by the way, I don't have to call it myFile. I could use anything that's all there, and I think we do in the next program. But you have to have some sort of a name for the file object. So because we're going to read the file, I'm going to print a little bit of a heading here first, and then we're going to read one line out of the file. Well, there is a read line function in our file object that we can use to read the entire line. We'll keep this going as long as there's something to read. This line here means keep reading as long as the value of PAL is not an empty string. Well, when you get to the end of the file, it will be an empty string, so that'll stop the loop. Now, you might recall that we appended a \n for a new line to the end of the string. Well, I'm going to take that off with the rstrip function. Rstrip means write strip. Strip the \n away from the right end of this string. There's also an lstrip, by the way, if you want to strip characters away from the left end of the string. But we're going to strip away the \n that we appended. And then we'll print the value of PAL. And you notice I'm using the end operator and specifying a single space. As you know, the end operator cancels the new line that print normally causes. So we should print all our PALs out on one line. But we've got to keep reading them. We have to read another PAL using myFile.readLine. Once again, it's an exact copy of this line up here. So this loop will continue to cycle until it gets to the end of the file, at which point this becomes false and it will stop. So let's see what this looks like. Once again, we should close it. So we'll give this a run, the F5 function key. And there's the output I got right there. As you can see, it printed out the names all on the same line. Now, if I'd left this line off, which I could do, just for the heck of it, I'll comment that line out and run the program again, just to show you the effect here. See what happened? It didn't print them all on one line because there was a \n in there. And actually, it's kind of interesting. We get an extra space here in front of these. But I wanted to print them all on the same line, so I had to strip away the \n in order to do that. Any question about that one? Everybody okay with why that runs the way it does?
Yes.
I'm sorry, could you say that again?
I was just saying that I got it.
I'm sorry, that didn't come through very clearly. Was that you, Jessica?
Yes, I was just saying that I do understand.
Oh, okay, good. Okay.
So I have a question just regarding the end of file print statement at the end. I see you have the escape sequence in front of end of life. Wouldn't it print on a new line? I know why it's printing on a new line, but why can't you do the same thing with putting it at the end of the? Oh, let's wait. Oh, no, I understand now. Okay, so yeah,
That's right, because here we didn't finish the line, right?
Right. I see
That's
that.
right. We didn't finish the line, and so I wanted to finish the line first, so I would do it there.
Okay.
Yeah. Good question. Okay. Well, all right, if you're okay with those two, I have a few more examples to show you. Just kill those off, kill off this window here. And let's take a look at, let's look at one called make file 2. Now in that particular case, we were dealing with names, which of course are strings, right? Well, this time, let's write some numbers to a file. And I thought it would be kind of cool to write some random numbers to the file so that we could go back and make use of the random module that we learned about some time ago, back in chapter 5, I think it was. So let's import the random module, and we'll give it an alias name of just R so that we can simplify how we use it. And I thought what we would do is let's generate some random numbers, all of them from 50 to 100, and copy them into a file, each number on its own line. So we'll use the open function again. This time we're going to call the file nums.txt. We're going to open it in write mode when we create the file. And this time I'm using just file as the file handle. Okay, just to show you that it doesn't have to be my file all the time. Use whatever you want. Now, I thought we would ask the user how many random numbers are desired. We'll get a number from the user, an int from the user, and then we'll use that with the range function and a for loop. Putting the how many in here means that this loop will run as many times as random numbers are desired. So that should create the correct number of random numbers. And here's how you actually create them. R represents the random module, and there's a function called Randint in the random module. And you can specify 50, 100 to get random numbers that range between 50 and 100 inclusive. You could get a 50 and you could get a 100. And then what we'll do is we'll write that num, that variable num, we'll write it to a file. But as I said earlier, all your input and output is with strings. So we have to convert that num into a string. We've got to convert it to a string using the str function. And because we want to put it on its own line, we'll once again append a \n to the end of that. So that'll write the number on its own line. And this should continue to cycle as many times as we want random numbers. And at the end, we'll get a message file was created and we'll close the file. So there's no user input except for this one line here. And after that, the program takes over. So let's give it a try. There we go. I'm going to go with, how about 12 random numbers. Done. Okay, apparently just like that, it made our 12 random numbers. We didn't print them out as we went, but let's see here. Here they are. Here are the 12 random numbers that were generated. They're all between 50 and 100, as you can see. Nothing lower than 50, nothing above 100. Might get some, I do have some duplicates, which is quite likely. But we do have our random numbers being generated, which is what this was all about. Okay, so we generated those random numbers, each on its own line, as you can see. Everybody okay with how this works? Here's a critical step right here. You've got to convert it to a string. If you try to just file write the num to a file, you'll get the red screen of death. The program will crash. Okay, so that was 12 random numbers. Let's look at another, the counterpart of this. Let's look at the read file for that one. So if we want to use that file, I thought we could read it. We'll read the numbers out of the file. So once again, we're going to be using the open function. There's the file name that we're going to be looking at. And now we're in read mode. So we have an R here. Once again, I called this file. By the way, I don't have to use the same name for the file handle in the make file and the read file, but I did. It doesn't have to be that way though. So then print a little bit of a heading here. Here are the random numbers. We'll read one line out of the file. And remember, it's a string. Even although I know it's a number that's inside of a string. It's a number inside quotes. So I'm going to call it num_str just to remind myself that I'm reading a string when I use the readLine function. And I'm going to continue to read numbers from the file until I read an empty string. In other words, when I get to the end of the file, I will have an empty string. So that should go through the entire file. Now we know that what we want to read is actually an integer. And so we can use the int function to convert that num string into an actual number. And then we could print it out. Again, we'll print all these numbers on one line by using the end operator, which cancels the new line. And then we'll read another line inside the loop. That's the continuation read. You always have your priming read before the loop starts, and then your continuation read inside the loop. So I'll just give that a quick run. And there's the output that I got. Let's see if that does match our nums.txt file. Yeah, it's got them from 63 to 55 all in one line. So we're reading them properly. Any question about that one? Once again, the key point is we're reading a string, but then we can convert it into an int inside the loop. Now, I thought it would be fun to modify this one slightly and do a little bit of analysis of the numbers that we got. Why don't we try a second version of this one? So I made another version of this one, which I called read file B. And here it is. Read file B, read file 2B, I guess it is. And the only thing I wanted to do is maybe analyze the numbers a little bit in several different ways. Like for instance, I'd like to add them all up. Let's add up all the numbers. And let's also determine, by the way, in order to do that, you have to create an accumulator, a variable that adds up the value of other variables is called an accumulator in programming. And you always initialize the accumulators to 0 before you start using them. And I'm also going to specify two counters. I'm going to count the odd numbers and the even numbers. And I'm going to set both of them to be 0. This is an interesting syntax that I don't think is anywhere in our book, that you can specify two variables at the same and give them an initial value if you want, like this. Now, once again, got pretty much the same code as before. We've got read a line out of the file. But after I read it, I'm going to add that value onto the total after I've converted it. Now, I have to convert it to an int before I can add it onto the total, right? And then I want to detect if it's even or not. And if it is, I'll add 1 onto the evens variable. If it's not even, of course, it has to be odd. And I'll add 1 onto the odds variable. And then we'll read another line out of the file. And then after, this is after the loop, we will print out what the total is, and we'll print out how many evens we found and how many odds we found. So it's just a slightly better version of the first read file program that we had. Let me give this one a run. And here's the output that we get from that. Here's the output. We did ask for 12 numbers. Apparently they add up to 836. And there's 4 evens. Let's just quickly check that. 66, 74, 96, and 76. Yeah, 4 evens. And of course, it would have to be 8 odds since there's 12 numbers altogether. Okay with that one? So this one is a good one because it brings up the idea of an accumulator and the idea of counters. Counters go up by 1. You always add 1 for counters. Accumulators, though, go up by the value of another variable. In this case, our num variable. And just for fun, I'd like to run that first makefile program again. This is the one that made the random numbers. So I'm going to run it again with a different number of random numbers. So here we go. I'm going to say we want, this time we want 16 random numbers. Okay, apparently we got them. Now let's run that analysis, that read file 2b, this enhanced read file that gives us some analysis. We'll run that again. Let's see what we get from these 16 numbers this time. Okay, there they are. I got a 100 that time. And apparently they all add up to 1200, which is interesting. And there were 10 evens and 6 odds. Let's count the odds. 1, 2, 3, 4, 5, 6 odds is correct. So 10 evens would also be correct. Any question about this one? This is something that's commonly done. By the way, we could further enhance this in many different ways. We could, of course, get the average of the random numbers, right? By dividing the total by the number divided by our the count. We could also add up the odd numbers and add up the even numbers if we wanted to. We could add a few more accumulators, all kinds of things that we could do. Once we have those random numbers in the file, we can analyze it, which is what happens all the time with data, right? Because you know that big data is the big thing in computing these days. Big data, reading files. Programs can read your Facebook files, and by reading your Facebook files, they can make determinations about your characteristics and your preferences, things you like and dislike. And then they can target you with certain types of advertising or information about how to vote, which is apparently what happened with that company, Cambridge Analytica. Well, they were doing things like this. They were reading data and crunching it through some pretty complex programs to determine how they could try to affect the election. Okay. Any question about this one? Okay. All right, well, we'll carry on and just have one more example to try. See, my ebook is timed out on me, but we can get back. I haven't used it much at all, actually. But the same kind of stuff is in the textbook, is what we're doing here tonight. just got one more that I wanted to show you, and that's a maybe a payroll type application. And you could actually use this one to work out your pay. I know most of you have at least part-time jobs. Some of you have full-time jobs, which is incredible while you're a student. I had a part-time job, but that's all the time I could afford when I was a student. Okay, so here we have, we're going to record our daily hours work to a file called hours.txt. So we're going to open that file in write mode with the W. I've used file again as the file handle, and that's the name of our file, hours.txt. Now, we're going to ask at the start, how many days did you work this week? And we'll store that in a variable called how many, and then we'll use that with the range function and for loop to make the for loop run exactly that many times. And each time in the for loop, we'll ask the user for the day of the week and then how many hours were worked on that day. So we'll be inputting a string and a float because it's possible that somebody could have worked a partial hour, of course. And then we'll write those inputs to the file. So we're going to be writing two things to the file this time in each loop cycle. We're going to write the day and then the hours, each on its own line in the file. And remember, the hours being a float, we have to convert it to a string with the str function. So let's give this one a try. Here's how it could run. Okay, let's say we worked 5 days. And maybe I didn't work Monday, but I worked Tuesday. And I worked 8 hours. And I worked Wednesday. Get the proper case in here, make it look good. And on Wednesday, maybe I worked overtime for 10 hours on Wednesday. And yeah, I worked Thursday as well. And I worked another 8-hour shift. Didn't work Friday, but I worked Saturday. And I worked 10 hours again. And then I also worked on Sunday. And I worked for 8 hours on Sunday. Remember, I indicated that I worked for 5 days. As soon as I went through 5 days, the loop stopped and the file was created. But I had 2 inputs in each loop cycle, as you can see, the day of the week and then the number of hours. Well, that created a file. Here's what that file looks like. It's always instructive to take a look at the file. The file contains the day of the week followed by the hours, each on its own line, as you can see. So now you know how we have to read this file. What we have to do is we have to read a string, and well, actually, we're going to read 2 strings, but the second one, we're going to convert it to a float after we read it so that we can add up the hours worked. At the end of this, we're going to calculate your pay. So there we have it. Now let's look at the second file, which is going to read that text file and calculate your pay. So I've called that one pay file 2, and it looks like this. We're going to read the work data, and then we're going to compute our weekly pay. So we change our mode to R when we want to read the file. We'll print a little summary header line here, and then we'll need an accumulator. We want to add up the weekly hours. We have to have an accumulator, and you always set an accumulator to 0. Then we need a priming read. Well, we know the structure of the file begins with the day of the week, so I'm going to use day as the variable and read a line out of the file. I'll start my loop then with the same syntax that we've had all along, using the while, and we're going to read as long as there's a value in the day variable. It'll stop as soon as we get to the end of the file. We're going to strip away the \n out of at the end using rstrip and continue to call it day. Notice I'm using day.rstrip\n and then reassigning it to day. So that basically just strips it off the end of the day variable. Then we have to read another line, but we know that it's the number. So we're going to convert that to a float like this. Okay, we'll convert it to a float. Once we've got that read, we can add it onto our total. So here's where the accumulation is happening right there. We're adding up the hours into the variable total. And then what we're going to do is we're going to print the day and how many hours were worked on that day. Then we have to read another line in the file. Here's the continuation read, which is an exact copy of the priming read up here. Once we're through, we'll close the file and we'll report the total hours worked, and we'll also determine what the pay is, including a calculation for overtime here, if I can get it on the screen. Okay, here it is. So we'll report the total hours worked, and then we'll ask the user to enter the hourly pay rate, which could also be a float, of course, since it's dollars and cents. And if the total is more than 40, well, to work out the pay, it would be 40 hours at the regular pay rate, and then any hours above 40 multiplied by the pay rate times 1.5. As you know, you get time and a half for working more than 40 hours. If, however, the hours are not greater than 40, it's just hours worked times pay rate. And then what we'll do is we'll print out the pay using the format function. We'll format it with 2 decimals here. And we'll put the $ right up against the first number in the pay by canceling the normal comma separator that we get, the usual space that we get from a comma separator. This sep operator, being an empty string, will cancel the space produced by the commas in my print statement. So let's see how this goes. Here we go. We'll give it a run. All right, it's gone through the file. It's reported all the data. 8 hours Tuesday, 10 hours Wednesday, 8 hours Thursday, 10 hours Saturday, 8 hours on Sunday, for a total of 44 hours. So obviously we're into an overtime situation here. To make this really easy to work out, I'm going to put in a low pay rate of $10 an hour, just so we can do the math fairly easily. And apparently that works out to a pay of $460. And why is that $460? Well, you get 40 hours at, 40 hours at $10 an hour. That's $400. And then you get 4 more hours at $15 an hour. That's an additional $60. $15 an hour for the time and a half, for the 4 hours that are over 40. So I think that's working properly. That's a little program that you could actually use to work out your pay. Of course, it doesn't include any taxes or deductions, but it at least gives you your gross pay for the week. So you could actually use that. Those are all the examples I had, folks. Any questions? I hope I didn't go too quickly, but that's about it. That's what we want you to know about files. The key things to remember: all your input and output is strings only. When you write to a file, you're writing a string. When you read from the file, you're reading a string. If that string contains a number, use the int or float function to convert it into the number. Todd, you had a question? Jessica?
No, I'm just trying to internalize what you just said, and just the whole, like, writing to a file and then reading it, and then what about, I'm just a little confused about appending when I'm reading. Okay. Yeah, there is an append mode too. When you use the write mode, if the file already exists, it gets erased and you start an entire new file. Now, in the append mode, what happens is it doesn't erase the existing file. It just adds on to the end of it. So if you wanted to enter your hours on a daily basis, like maybe Monday night, you want to enter the hours you worked on Monday, you would change that program to append mode. Instead of W, put an A in there, and then it would
would not erase the file when you entered your hours on Tuesday. It would just add on to it.
Okay, so but like when you write, so when you're reading a file though, I mean, you're basically manipulating the way you're manipulating the data, how it reads. Like I'm seeing all this, like
You're reading lines. Just basically, you're going to be reading lines, but those lines are going to be strings. If that line contained the string on that line, if it had a number in it, maybe a float, maybe an int, you have to convert it using the appropriate function, either int or float, if you need to do any arithmetic with the value.
okay,
That's the key.
gotcha.
Like in this particular case, we wanted to add up the hours. So we can't add, if we tried to add two strings together, you get an interesting effect. Like, I guess I could type it down here. But if you added two strings like 8 hours together, let's see here. Okay. I'll do it up here. If you had one variable like maybe hour 1 equals 12 as a string, and next time if you had hour equals 10 also as a string, if you try to add those together as strings, guess what your total is going to be? If you add them together, you would end up with a big string 1210. It adds them together, like it just appends them, really is what it does. It doesn't really do the math at all. You want to do the math, you have to convert these from strings into ints in this particular case.
Okay, I got it.
Okay. Any questions? How about you, Jessica? Any question about that one?
I have a question. You see where it says while day is not equal to an empty string,
Right.
do you have to specify like what to do if they do enter an empty string, or does it automatically just ends the program?
Well, remember, right now, we're not entering anything.
Mm-hmm.
Like, we're not entering anything. What we're doing is reading the file. All the input is coming from the file in this program. Now, in the first program, when we created the file,
mm-hmm.
we ended the inputs by pressing enter. Well, actually, we didn't. It was a for loop, I guess, in that one. But when you get to the end of the file, like let's just look at the file for a second here. It was called hours. Here's the file. So see, when you try to read past here, that's going to be an empty string. See, you read this, you read that, and you get an empty string. So that stops the file.
Okay, I see.
Okay. Good question, though. Very good question. Any other questions about this one? Well, there's a very good preparation exercise for this chapter in your course page. It's a very good one. I encourage you to try it. You want to make sure you're doing all of these before you try the actual assignment, right? They should prepare you for the actual assignment. And they're worth points. Don't forget to do them. Okay, those are worth grade points. Well, that's about all I have. I guess we're finishing up a little bit early. We've only got one more chapter to do after this, and it's a really interesting one. It's about lists, how to make a list, a special type of data that contains multiple values. And they're extremely powerful. And all programming languages have them, although usually they're called an array in most programming languages. So we'll do that next week, chapter 7. Just remember not to go past page 324, where you get to exceptions. That's where we stop. for this chapter. Exception starts right there, and you're not responsible for anything after that point. Some pretty good examples in the textbook as well. Any questions? Anything I can do for you folks? Would you like to see another example? We can make one up if you wanted. You want to work through one together while you follow along on your computer?
Sure.
That can be very effective. I think we have time if you want. Why don't we try something like that? I'm going to check out your assignment just to make sure that I don't do it by mistake. Because I sometimes do that because it's rolling around in my mind in my memory. Okay, no, we'll do something completely different from that. Let's try one that we make up. We'll make our own up here. Okay, so let's make up one called grades. Okay, we'll make one up called grades, and what we'll do here is we'll call this grades 1 because the first thing that we're going to do is enter some grades. But to make this really quick, actually, to make this really quick, because we are a bit pressed for time here, what we'll do is we'll just make the file with our computer without using the Python to make it. So here's what I'm thinking. If I just right-click on my desktop and select New, I can create a new text document. I think you can do the same with the Mac if somebody has a Mac. So I'm going to do that. I'm going to create a new text document, and I'm going to call it grades.text. Okay, it's going to be called grades.text. And here's what I'm going to put in that file. I'm going to put in it math 88 comp 92 ethics 76 and what's another subject that you guys might take? About chemistry, and you got 84 in chemistry. Okay, so what I've got here is a list of subjects. Now notice I pressed enter on the 84, so we can read this file until we get to this empty line here. So I'll just hit file save on this. So now we have that file. Let's just write a quick program that's going to read it. So we're going to open grades.text. If you can follow along here, we're going to open grades.text in read mode. So we're going to change this to be grades. I don't know if you can follow along. I hope you're able to do it. And this, we could say here's a summary of your grades in this case. I do want to add up the grades because I would like to get the average. So I'm going to leave that total in there. And now I'm going to have my priming read. Now, obviously, I'm not reading a day. I'm reading a subject. Well, I'm just going to call that subj as a short form, okay? And we know that that's a string. So I'm going to read the subject. I'm going to change this to subject. And I'm going to change this as well. Everywhere where I had day, I'll just change this to subject. So what I'm going to be reading is a subject out of the file. And then I'm going to read the, we'll call it the score out of the file that will read the grade score as a percentage. Okay, so that we're going to read the score. And we have to convert that into, I guess an int would do, wouldn't it, in this particular case? I don't have any float numbers in my percentage scores here. So I'll just go with int. And then I'll accumulate my all my scores. So I'll add the score onto the total so I can get the average later from that. And then I'll print the subject, followed by the score. And just to save time, I'm going to delete this. And then we have the continuation rate, which is an exact copy of what we have up there. So we have to repeat reading the subject. And then we'll close the file. And obviously, none of this really applies, so I'm going to erase it all, pretty much. And what we could do is we could say, hey, you know what? We need to count how many grades we read, right? So I think we need a counter here too. So right up near the top, I'm going to create a variable called count and give it a value of 0. And this will be a counter that should count the number of courses so that I can get the average properly. We need a proper count. Do this line up properly here. Okay, so this is going to be a counter. And every time after we read a score, I think that's where we should increment the counter. So we'll do it right here, even right above this. Count plus equals 1. That'll add 1 onto the count. Now we can use that to find the average, right? We're going to divide by the count. So after we printed out everything, we close the file, and we could get the average score. Average. Say average is, and what we have to do is total divided by the count, right? Total divided by the count. Now, that could produce an ugly decimal. Let's see if it does. If it does, we'll have to use the format function. Make it look better. So I'm going to save this as grades.py and try to run it. Save as. And I'm putting all these in a folder here. So I'm going to call it grades.py. And I'm going to give it a try. I might have something wrong here. We did it kind of quickly. Let's see what happens. Here we go with that 5 function key. And there's the output I got. It represented all the subject and then the score. And the average is apparently 85.0. Got lucky where I didn't get a bad decimal. Okay. So once again, we were reading a string, and then we were reading an int, so we had to make sure we converted it, because everything is a string. But if I want to do any kind of arithmetic, like we do want, where with the counter and the accumulator, I've got to convert it. Well, I hope that's enough. That's pretty much it as far as the skills that we want you to have in this chapter. Any more questions about that at all?
No.
I'm sure you had trouble following along with that. So this will be included in the zip file that I put in our course. And by the way, here's where I put everything, just in case you didn't know. In our course, in the course content, if you look near the bottom of the table of contents, you will see something called links and resources. And each week, I upload the video that we're recording here to YouTube. There's last week's video on functions and the lesson, and the example programs are here. So in about half an hour or so, you will see the new one for today's lesson, plus the files that we used today will be here. So you could review them if you want. So that's all I have for you folks. If you have no more further questions, I'm done.
Thank you.
All right.
Thank you.
Brad out. Thanks for attending. I appreciate it. And I hope it helps. Take care.